So we are reviewing systems of equations from grade 10, and we're going to extend this idea into quadratic systems of equation. So first of all, what is a system of equations? A system of equations is when you have two unknown values, x and y, and two equations or relationships of x and y. And we can actually have systems of equations with more than two variables. We can have a three-variable system. To solve a three-variable system, though, we would need three relationships. Okay, so we're going to focus on two variables, two equations, and just make sure we understand how does this differ from a linear system of equations, or sorry, how does the system of equations differ from a linear equation? So equation for x is when you're like finding two cars kind of going different speeds and collide us on the number line in one dimension. So basically an equation with just one variable has a one-dimensional solution. It just has a solution along the number line at some point x. When we have a system where we have x and y, we now have two variables. So when we have two variables, we're talking about a two-dimensional relationship. In a two-dimensional relationship, when we find where the two relationships are going to intersect or meet, we end up having a coordinate, an xy coordinate. So in a system of equations, we're going to have both an x and y solution, and it's a two-dimensional solution. So systems we can characterize by a two-variable system really is a two-dimensional solution, okay, or a position with x and y. Okay, so we have to solve for x and y, and for that matter, we can extend it to three variables. So a three-variable system would be a three-dimensional problem, and the solution is going to be a position in three-dimensional space, okay, so, or an x, y, and z. So we're going to go and solve some equations. Okay, so what is a non-system, okay, or an equation in terms of x, or a one variable equation? How do we solve that by graphing? So we're going to focus on graphing today. So when we have an equation, x squared minus 3x equals 1, notice it's a one variable. Okay, so it is not a system, it's a one variable equation. If I were to solve this, what I want to do is I want to make it equal to 0. X squared minus 3x minus 4 equals 0. And if I graph this equation, x squared minus 3x minus 4. If I were to graph this, this is a parabola, okay, and it's going to look something like this. And I can find the solutions where the graph crosses the x-axis. And some of you may have factored this and solved, but we can solve it by graphing as well. We're going to end up with x equals -1. Okay, and we're going to end up a solution at x equals +4. Okay, so when we have a solution, a one variable or one-dimensional solution, we're going to find a one-dimensional equation has a one-dimensional solution along the number line or along the x-axis, just along the x-axis here. Okay, so when we find where do we find a solution for x on the graph? We find where the graph crosses the line y equals 0. So how does this differ when we solve a system by graphing? Okay, so a system involves two equations. So if I have an equation y equals 3x minus 5, okay, so I'm going to have a graph. It's going to have a slope of 3. Okay, it's going to go like that. And I have another equation, negative 2x plus 5. So that's going to have a slightly less slope. It's going to go through 5 like that. Okay, and we're going to find a solution to this system. Well, the solution to this system is going to be where the two graphs intersect. It will be the intersection of the two lines. Okay, an x and a y position. So in this case here, if we were to solve this, it looks like we get x is equal to, it would look like x is equal to 2. Okay, so the position is 2, and when x is equal to 2, y is equal to 1. Okay, and if we were to check this, we can see that it does fit into both equations. When x is equal to 2, y is 1, x is equal to 2, y is 1. Okay, so that my solution is then x equals 2, y equals 1, and a two-variable system has a solution for both x and y.